is yours.
Thank you very much, Philippe. Yeah, today I would like to speak on behalf of my geological survey organization and also on behalf of EuroGeoSurveys and behalf of the MUSE project, because the topic of my talk will be about management geothermal energy in urban environments, and which roles geological survey organizations could provide. So this thing perfectly picks up the talk of Estelle, and I would like to also pick up some of your arguments, Philippe, you gave in your presentation. So I would like to start my presentation about talking why it's important to look about novel management concepts of geothermal, shallow geothermal energy in urban environments. What are the major dilemmas and their implications? What would be a way forward or out of these dilemmas by so-called integrative management approaches? And which is the role of geological survey organization in such a process? And then I would briefly talk about MUSE, so be a link to this management in cities. And yeah, I would like to link EuroGeoSurveys with the geothermal decade and give an outlook on what we would like to do in the next years. So why talking about managing shallow geothermal in urban areas? First of all, it's clear that Europe already has a very high share of urbanization compared to the rest of the world, and it will raise. It will raise from currently 75% to approximately 85% in 2050. So cities will grow. And when cities grow, you have to think about, let's say, a sustainable and green transformation. That means not just get rid of greenhouse gases, which is in line with EU policies. I think we don't need to talk about these goals, but it's about also life quality. That means reduce aerosols as emissions, but not just aerosols and smoke, but also waste heat. And Philippe mentioned the importance of cooling in the future, and we also have to think about how to avoid, let's say, overheating of the cities during heat waves in summer. And that's also waste heat is a same. I think it's the same level of importance like aerosols when it comes to emissions. So all this development, all these activities, they produce stress to the subsurface. On one hand, of course, most of you are well aware the urban heat island effects on the streets. This is also pushing to the subsurface. As you see on the left-hand side, this is an example for Vienna, my hometown. When you see that the annual surface temperature increased for 3 degrees Celsius in the past 40 years, and this prolongs to the subsurface. On the other hand, the stress addressed to the subsurface is also about spatial planning, how to use the subsurface in the most meaningful, most efficient way. So we want to use it for tunnels, for traffic lines. We want to use it, of course, for shallow geothermal. And we have to think about all this infrastructure that they might not interfere with each other. So as Philippe mentioned before, the shallow geothermal is a developing and a quite dynamic market. And you see this on this sketch here. I took the same numbers from the EGEC market report, and I tried to make a little bit different analysis. So you see on the x-axis, you see the diffusion. So number of installed units per 1,000 households. And on the y-axis, the growth rate. And you can see if you put a rough average to this cross plot, you see that there is a clear timeline. So it's from emerging markets where you can see Spain in the moment with a very low diffusion to very major markets like Sweden. And you have to think about that 12% of all households, this is on the household level, already use ground source heat pumps in Sweden, which is a really high number. And Philippe mentioned 2% in European average. That's around where Austria a little bit more is in the moment. And these boundary conditions are very dynamic. You cannot just linear extrapolate to the future because you don't know what will happen. There might be influencing factors by funding, by policies, but also by other incidents which dominate the market and may lead to a shift of interest from fossil or other renewable sources towards geothermal. And you can see this also. This goes in two directions. So we have countries which are really boosting, like Estonia, countries where it's still this trend was reduced and they are more lacking to a low diffusion rate. But however, I think from a certain level of diffusion, we have to think about new management approaches and which look to more integrative, not look at each system as an individual, unique case. This was is maybe still okay for low diffusion countries, but not for high diffusion one. I put here arbitrary, it's my own estimation, a threshold of around maybe 1 to 5%. When you reach this, you should think about integrative management. Also, the systems change. So we, in the last 20, 30 years, we looked at individual homes, single family homes. We have the classical use of geothermal energy in groundwater, open loop systems, or voltage exchangers, horizontal collectors. But now we see, and this was mentioned by Philippe, that they go to different applications. We are shifting from a source to a storage. So geothermal changes its role, it becomes larger. It connects several buildings, and this is also what we have to look in urban environments, because in most cities we have a relatively low share of single family homes in cities. So there are new aspects we have to look in management. And I would like to now point to the dilemma. So this is what I observe in my work. The first dilemma is that first come, first served. This is applied in most European countries. And this is against a kind of prioritization of use, because first come, first served means the first one who announces an interest gets it, unless no other is in the surrounding. This is fine when you start, because it's a very simple way of managing systems. But it comes to a certain limit when you have a lot of installations, and they may start interfering, and it's not the best way to prioritize a use just on the time you submit it. There might be more meaningful uses. And this goes well in hand with a kind of linear governance procedure. So you apply at your licensing authority, you deliver your documents, you get the permission, you install it, you operate it, and that's it. There is no feedback loop to the beginning phase. This brings a lack of information. The next one is, of course, a dilemma. We want to promote renewables, want to promote shallow geothermal. On the other hand, we want to protect the environment. And this is also, if you look at the EU Green Deal, you have these two interest axes, the supplying clean energy and avoiding zero pollution. And sometimes authorities, they cannot really very much cope with it, because they want to protect groundwater aquifers. On the other hand, they should promote renewables. So that's a kind of a dilemma situation, and leads to first rigid thresholds for operation. So let's say temperature levels, you are limited to your use. It also may lead to a lack of capitalizing synergies if you look at these 2 points in a different way. And of course, reluctant authorities, that means that they do not really follow the trends and the probably state of the art because they also have other things to do. It's totally understandable. This goes also very much in line with antiquated procedures and new technological developments. So there are new parameters we should look at, like storability in the subsurface, or balanced use cannot be treated as a pure heating, pure cooling use. This is all also about training and educating licensing authorities. So what are the management goals if you look at this? So we have to distinguish between individual interests of each operator and community interests of the urban environment. So individual are more looking on high system efficiencies, high system sustainability. So you should be sure that your investment stays valid for the next decades. And of course, interested in the reduction of legal barriers so that you get easier to your permit. On the community side, you look at efficient use of the urban subsurface, or also thinking about competition between different uses, type of uses. a minimum environmental impact. The management should be flexibility and adaptable, and it should be an access to data for decision making. This is the most critical point in my point of view. And several earlier studies and also proposing the kind of cycled management approach. That means that you don't have a linear procedure of providing a license. You have a feedback loop, a continuous, and you can be adaptable. And this works only if you have a bidirectional communication. It means not just the operator communicates on a continuous level with authorities and vice versa. You have to need to have an interface to facilitate this communication that normally would be web-based information systems. And that is very much important. You link those data you receive and you communicate during the licensing and operational process to environmental energy planning instruments, which are regularly updated. Of course, this sounds very nice and let's say supportive, but there are of course some tricky things linked to it. The first, who takes care about data management? How can this be financed? And are the competences available? Because local authorities, they might lack of these resources to take care about it. And now it comes to the geological survey organizations, and I'm representing a national geological survey organization. So what are our expertises? We collect data, we have expertise on the subsurface and different disciplines. That's very important, not just one particular one. We connect different disciplines. We have a role in communicating our knowledge, our data to the public and to our stakeholders. We do consultation, and normally on the national level, we are not directly linked into the regulation procedure. This is more on the regional, local level. And all these aspects of the integrative management approach is somehow linked at different stages to the National Geological Survey organizations. So we started information systems where we are in favor of communicating our data, which we assess. About sustainability and environment, the same with governments and efficient use, we would be more in a consultation role. We are not any decision makers. And managing resources, this is also once again linked to information systems, is an interaction of our data we collect and our expertise we propose to make plans. And then we look at a European level, and this is how we are connected to EuroGeoSurvey, which is an association of all national geological and regional geological surveys of Europe. And there is an added value to do so, and I pointed out here on my slide. It's a pooling of and transferring of expertise. As you saw on my previous slide, there are countries with a very high diffusion rate of shallow geothermal. They have a lot of knowledge, and other countries, they are at the earlier stage of this process. And it's very important to balance, to transfer experiences to those countries to avoid pitfalls and in management and in regulation. We are addressing transnational issues, and what is also very important, because shallow geothermal is more a local topic, not a pan-European when it comes to data, but we can offer a joint data infrastructure, and this is represented by the European Geodata Infrastructure, EGDI. And by cooperating, I'd like to enhance the impact of our national geological survey organizations by comparing the situations in different countries. We get arguments we can provide to our national stakeholders. And of course, this is looking also in the future. It would be very important when it comes to European decisions that also EuroGeoSurveys is regarded as a consultant from the geological point of view. So that's why we started MUSE. And MUSE stands for Managing Urban Shallow Geothermal Energy. It's a GeoERA project. So GeoERA was an ERA-net initiative of European Geological Surveys. There are 45 different projects, and MUSE is the one addressing shallow geothermal. And you can see on this map that we cover quite a lot of countries. So we have 16 geological survey organizations. Unfortunately, we have a gap in Central Europe, from Italy to Germany, but we are covering Western, Eastern Southern and Northern Europe. It's a 3-year project, and what you should consider, it's not a classical project like a Horizon 2020. It's more we have a very high in-kind share, so it's more a capitalization starting point to put shallow geothermal into the portfolio of European Geological Survey. And once again, I show you this picture of this management cycle with the different stages. So this is from the Geoplasma C project. It's very similar what I showed before. And we provide input on the different stages. We are collecting different methods how to map resources, limitation of use. We compile them and pull them to a kind of a catalog. We are working on a prototype of collecting this data on 2D web information systems at EGDI. We are looking at and analyzing governance strategies, governance and strategies for energy supply in the 15 participating countries in MUSE. We derive sustainable management approaches. What we will not do, because this is outside of our scope, is that we look at technical standards on installation and operation. This is not what we address in MUSE. And the main questions of MUSE will end 2021 in October, so in almost 1 year. What will be afterwards? So we will have a kind of a prototype for this EGDI web information system, which can be used by any other geological survey on it's made for a local data consideration, the local data displayment. We also linked it to a knowledge repository. What I have to mention, everything is in line with European standards. This is a very tricky thing. We have to be INSPIRE conformity. We have to apply very high standards of geological surveys to present our data. So this is a very modern way how to describe and present data. But we would like to go further, and we are looking forward to the Horizon Europe. Call next year. There will be one topic concerning the coordinated support action to transfer EuroGeoSurveys into a geological service for you by a stronger tide. And we would like to integrate shallow geothermal also in this next step by expanding our catalogs, our management concepts. And what is also, I think, very important is that we want to establish EGDI to be a kind of a knowledge container repository for those maps, for those web data sets which have been produced by previous European projects, but which now stopped, which now came to the life end, and we want to take care about this data as well and use the EGDI infrastructure to make it accessible even after the end of the lifetime. And this CSA, Coordinated Support Action, will end in 2026, and we will see where shallow geothermal will be at this stage. So I hope that the geothermal decade will really come, and that we can strengthen our role as geological survey to support the sustainable development of the subsurface and the sustainable development of shallow geothermal energy use. So thanks a lot for listening to my talk, and please have a look on the MUSE website, so you find more details about what we are doing in detail. Thanks a lot.
Thank you, Gregor, for this really interesting and detailed presentation.